Okay, this is the P4 paper from October 2020. It's question number 5. As we can see by looking at it, we've got integration. That part A is going to be integration by parts, and then we've got finding the area under a curve here, which again will be using integration. So let's have a look at part A. Part A says, quite simple in the question, can we find the integral of log x over x squared dx? So we're going to recognize this as being an integration by parts, and it's a particular type where if you have log x in any of your integration by parts, that has to be your u. So your dv by dx is going to be 1 over x squared. Now you can write 1 over x squared, or you can write x to the minus 2, because we're going to need to integrate it. So we may as well need to write it in the right sort of format there. The whole point about doing this then is that when I do du by dx, I can differentiate log x really quickly as being 1 over x. And when I integrate x to the minus 2, add 1 onto the power, becomes x to the minus 1. Divide by the new power, becomes minus 1 x to the minus 1. Or in other words, minus 1 over x, or minus x to the minus 1. When we're doing it, the whole point about doing integration by parts is that we've got that the integral of u dv dx is equal to uv minus the integral of v du dx. So it's just a matter of substituting everything in. uv is there and there, so that's going to be minus 1 over x log x minus the integral of, and then this should be something that we can either integrate or something that at least got simpler than our original problem up there. In this case, and it always tends to be the bottom two if you set it out the way that I've set it out here. So it's minus the integral of minus 1 over x times 1 over x. So that's minus 1 over x squared dx. Okay, so that works out to be minus 1 over x log x. The minus and the minus cancel out, so we get the integral of x to the minus 2 dx. I could have done it straight away, but we're just taking it nice and easily, which is then going to be minus 1 over x log x. The integral of x to the minus 2, as we just said, add 1 onto the power, divide by the new power, becomes minus 1 over x, and then obviously we need to have our constant of integration in there. So, part A done. Part B then says we've got the sketch here, and what they want to do is to work out the exact area of R. So the exact area of R is going to be the integral of y dx between 2 and 4. So let's actually go and do that as part of my answer. Put it down here, tell the examiner what I'm doing. So for part B, move this over, just say R is equal to the integral of y dx between the limits a and b, between the limits 4 and 2. So this is going to be the integral between 4 and 2 of the curve, which was 3 plus 2x plus log x all over x squared dx. So it's another type of integration. You might be thinking, well, what do I do here? Sort of the clue, I think, is the fact that we've actually got log x over x squared there. So what that shows me, that's the first part. So what that shows me is that if I divide everything by the x squared, then I'll get 3 over x squared plus 2x over x squared plus log x over x squared dx. Well, we know the answer to that little bit there. For the rest of it then, just take your time. So that's 3x to the minus 2, plus that's 2 over x, isn't it? So 2 over x, and then log x over x squared. We still haven't integrated yet, so between 4 and 2 the integral, and now we should be able to do all of those. So the first part, 3x to the minus 2, with P4, I'm just going to go through these quickly. You should be able to do these. Very, very straightforward. Add 1 onto the power, divide by the new power. That's going to give me minus 3 over x, or minus 3x to the minus 1 if you want to write it like that, 2 over x, you should absolutely know, is 2 log x. And then the other part of it, that's what we've already got. We've already got, I'm going to write minus 1 over x log x minus 1 over x, because all of this part here is actually the first part of the question. So we're doing that now between 4 and 2. So when we're doing that, we could just tidy that up a little bit. For example, when we're looking this term and this term, minus 3 over x minus another 1 over x, that's going to be minus 4 over x, isn't it? So if I would just want to make that a little bit neater before I do it, this is 2 log x minus 1 over x log x, and then minus 4 over x that we're doing between 4 and 2. It said give me the exact value, so they might have a little bit of a play around with logs in a second, but let's put everything in. This is going to be, okay, 2 log 4 minus 1 over 4 log 4 minus 4 over 4. That's putting the 4 in, minus, now putting the 2 in, 2 log 2 minus 1 over 2 log 2 minus 4 over 2. So if we're trying to sort all that out, then what have we got? Well, we've got, let's have a look at this. 2 log 4 minus a quarter log 4, that's going to be 7 over 4 log 4. Minus 4 over 4 is just minus 1. And then 2 log 2 minus a half log 2 is 3 over 2 log 2. It's obviously a minus. Minus 3 over 2 log 2. And then that's going to be minus minus 2. So that's going to be plus 2. So here we just want to combine these two logs here. What I'm going to do is I'm going to make them into log 2 squared. You can do it, you can take as long as you want or as little as you want with this, but if we actually just to explain it, 7 over 4 log 4 is log 2 squared. The minus 1 and the plus 1, we'll sort that out in a second. Minus 1 plus 2, sorry, that's just going to be plus 1 here. And the whole point about doing that now is that I've got 14 over 4 log 2, because I can bring that power down and make it a multiple. So I've got 14 over 4 log 2 minus 3 over 2 log 2 plus 1. And then 14 over 4 is 7 over 2 minus 3. Anyway, it works out to be 2 log 2 plus 1 here. Let's go back and see what they asked for. They just asked for the exact value. So sometimes they'll do things like saying, ask for it in the form log of A plus B or C log A plus B. But here, they haven't said anything. They've just said, can we have it as an exact answer? And that is an exact answer as we're going through and doing it. Just be careful with this last little bit. Sometimes do lots of them to get the experience of the different techniques they can ask us to do. Apart from that, relatively straightforward question. Hopefully that all makes sense to everyone.